Hello students, today we will be discussing some numerical problems based on work, power and energy. Starting with our first question. A spherical metal ball of mass 0.5 kg moving with a speed of 0.5 meter per second on a smooth linear track collides with head-on another ball at rest, assuming this event to be perfectly elastic. Find speed after collision. Now, in this case, we are given two balls. Let us mark it ball A and ball B. If we are talking of ball A, then the mass of a ball A is given to us as 0.5 kg. Let it be m1. Now, it is given that the balls are identical. It means that M2 is also 0.5 kg. Now, it is given that the ball A is moving with some velocity. So, let it be U1 and it is given to us that it is 0.5 meter per second. Now it collides with a ball which is at rest, means the second ball is at rest. It says that U2 is 0 meter per second. Now let us consider that the speed of the ball after collision. So let speed of ball A is V1 and B is V2. So these are the final velocities of the ball A and ball B after collision. Now we know that in such questions we apply either the coefficient of restitution formulas or we apply the conservation of momentum or we apply the conservation of kinetic energy. It completely depends upon the information which is given to us in the question. So by applying conservation of momentum. By applying this conservation of momentum, we will be getting that m1 u1 plus m2 u2 must be equal to m1 v1 plus m2 v2. Now, according to the information given to us, 0.5 that is m1 into 0.5 that is u1 plus 0.5 that is m2 multiplied by 0 that is u2 again equals to m1 that is 0.5 into v1 which is considered by us in m2 again 0.5 and to v2 that is assumed by us. So by solving it we will be getting v1 plus v2 is equal to 0.5. Let us mark it as equation number 1. Now in our question it is given that the collision is perfectly elastic. Now in perfectly elastic collisions the kinetic energy remains conserved. So by applying conservation of kinetic energy, it means that the kinetic energy before collision is equal to kinetic energy after collision. If we talk of before collision, then starting with ball A1, it is half m u1 square plus kinetic energy of the ball B initial, that is half m2 u2 square equals to final kinetic energy initially of ball A m1 v1 square plus half into V2 square. Now substituting the values, half, we know that M1 is 0.5, U1 is again 0.5. The initial kinetic energy of the ball B will be 0 because it is given that it is at rest. So final kinetic energies will be half M1, that is 0.5 into V1 square, plus half M2, that is 0.5 again, and V2 square. On solving this equation, we will be getting V1 square plus V2 square as 0.5 whole square. Let it mark it as equation number 2. Now we have two variables and two equations. So we can solve them mathematically. By solving these two equations mathematically, we will be getting V1 as 0 meter per second, while V2 as 0.5 meter per second. So these are the respective velocities of ball A and ball B after the elastic collision. So whenever it is said that the event or the collision is perfectly elastic, so it's better to use the conservation of kinetic energy. Let us discuss next question. Question number 2. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and the efficiency of the pump is 30%, how much power is consumed by the pump? Now in this question we have to evaluate the power which is consumed by the pump in pumping the water to some height. Starting with this question, we are given that the tank has a volume of 30 meter cube. So by the volume we can also evaluate the mass of the water. So to evaluate the mass of water, we will be using one relation, that is density. We know that density is mass per unit volume. So by this relation, if we want mass, then it would be density into volume. So mass of water is equals to density of water into volume. Now in question we are given that volume of water or the volume of the tank is 30 meter cube and density of water in the SI system is 1000. So the mass of water will be 3 into 10 raised to the power 4 kg. Now it is asking us about the power. So now we want the output power. Output power will be, we know power is rate of doing work, that is work upon time or the work done per unit time. Now it is said to us that it is pumping the water to some height. So in such a case, work will be mgh over t. Now, just now we have calculated the mass of water. The mass of water is 3 into 10 raised to the power 4 into g, that is acceleration due to gravity, has a fixed value 9.8 meter per second square, and h, that is height, which is given to us in the question, that is 40 meter above the ground, divided by time. It is given to us that it does this work in 15 minutes. This 15 minute has to be converted into seconds because we are taking all the things in their SI system. So 15 into 60. On calculating it mathematically, we will be getting 39200 over 3 watt. So this is the output power. Now we are given the efficiency also. It is said that the efficiency of the pump is 30%. So efficiency, we know efficiency is output power over input power into 100. So efficiency is output upon input. As we are talking of power, so that will become output power by input power into 100. Now in this case we again want input power. So input power will become output power, which we have just now calculated, over efficiency, which is given to us, into 100. So output power is 39200 over 3. Efficiency is 30. So into 30 into 100. Solving it mathematically, we will be getting 43.6 into 10 raised to the power 3 watt, which may also be written as 43.6 kilowatt. So this is a input power of this pump. Let us talk of another question. Question number 3. A body of mass 1 kg initially at rest explodes and breaks into 3 parts of masses in the ratio 1:1. The two pieces of the equal masses fly off the perpendicular to each other with a speed of 30 meter per second each. What is the velocity of the third fragment or the third part? In this question we are given that there is a body of mass 1 kg which is initially at rest. Due to some internal forces or due to some reasons, it explodes into 3 parts. When it is exploded into 3 parts, the masses which split off are in the ratio of 1:1:3. Now, according to the ratio which is given to us, the two pieces must be having equal masses. So the masses which are of same mass fly off perpendicular to each other, and their speeds are also given to us, that is 30 meter per second each. We have to find the speed of the third fragment or the third part which is flying off. Now in this question, first let us draw it diagrammatically, which makes us easier to visualize the component of the velocities. Let us consider that this is part M3 and it is moving off in this direction with velocity v3. Now it is given to us that remaining two fragments fly off perpendicular. So let it be v1 and mass be m1, and let it be v2 and mass be m2. Now it is given to us that they are perpendicular. It means the angle this is 45 degree. This angle is of 45 degree again. What we get is this angle as 135 degree. Again this angle as 135 degree. So we can visualize that how these fragments are flying off. Now we are given m1 is to m2 is to m3 is 1:1:3, but it is again given to us that m1 plus m2 plus m3 is equal to 1 kg. Therefore we will be getting m1 as 0.2 kg and M2 again as 0.2 kg and M3 again as point. In first question only we discussed that if there is a such question, then it is better to apply the conservation laws. In this case, we will be applying the law of conservation of momentum. So by law of conservation of momentum. Now while applying this law, that is momentum is m into v, we know, and the v is a vector quantity. Now in this question, if you are applying this law, then all the velocities should be taken along the same direction. So according to this law, m3v3 must be equal to m1v1 plus m2v2. Now it's better to take v1 and v2 along v3. So m3 into v3 plus m1. Now if we talk of v1, then taking in this direction, that will give us v1 cos 45 degree. Again taking v2 in this direction will give v2 cos 45 degree. So while applying the conservation law, use these values of v1 as well as v2. So m1 v1 cos 45 degree plus m2 v2 cos 45 degree. Now substituting the given values, we know m3 is 0.6, v3 has to be calculated, m1 is 0.2, v1 is 30, we know cos 45 is 1 over root 2 plus 0.2, that is into 30, that is v2 into 1 over root 2, that is value of cos 45. Now solving it mathematically, we will be getting v3 as 8.484 over 0.6. Hence v3 will be 14.14 meter per second. So whenever it is given that a particle is exploding into many parts, so it is better to draw a diagram so that we can make the directions easily and then apply the law of conservation of momentum. So we can say that the third fragment has a velocity of 14.14 meter per second, making an angle of 135 degree with each fragment. As we have stated that 135 degree is the angle between them. So we can also write making angle of 135 degree with each of the other fragments. Okay, thank you students.